So it always depends what they did last year. You guys did see this notation in pre-cal?
I did.
Okay, you did not.
I did.
You did. Okay. Computer science people, do you see this notation anywhere? Not really. Oh my goodness. On computer science, we used it a lot. They're for loops. Okay, what does the sigma mean?
Summation.
Summation means add. Does anybody know what that thing is called?
A variable.
Specifically, it's an index. An index is what place in line. You're first in line, you're second in line, you're third in line. Can you be 5.2 in line? No. So it counts up by ones. We're not going to go, you're first in line, get you. You're second or third in line. We're going to skip every even number. No. You go up one at a time. So it's like processing. We processed your stuff, we processed your stuff, next one, next one, next one. Go up by ones. So how to do this, starting at k equals 1, plug that k value in. 5 times 1 minus 2 is 3. Does that index equal the number up top? Does 1 equal 3? No. So as you said, summation. Add, then kick the index up 1. Process this one, moving on to the next person. At 2, 5 times 2 is 10, minus 2 is 8. Does 2 equal that top number? No. Okay, summation. Kick the index up 1. We're now processing person number 3. 15 times, or 5 times 3 is 15, subtract 2. Add them all together. So this is expand, that's evaluate. Yeah? We don't do a lot with this right here. Comes back to the vengeance in chapter 9 with a vengeance. But what I want to show you today is some stuff that comes up very rarely on the AP exam. And I don't test it, but I need to give you a fighting chance if it shows up, and it did show up last year. So.
And it blindsided many people?
I don't know. AB was the group that I showed it last year, and I'm looking for the thing. AB did not get shown that, so, and I'm trying to just bring this up, which I thought I had up. And this is a way that they might show you or ask questions. They will say, all right, we're going to do this as the sum of 1, 2, 3, 4, 5, 6 rectangles. So whatever dx is going to be a constant. This is 6 things cut into 6 pieces, so this is going to be a 1, because from the start to the finish, -3 to 3 was 6 units. I wanted 6 pieces, so dx is 1. And then this one is using RRAM, starting at -3. I took 1 step n of how big of a step. And I don't know why they're not drawn on top of where they're supposed to be, but
Would it be -3 plus?
yeah. Plus n times however big that step is. So they can ask stuff like this. This is the kind of thing that was last year. It was, I can't change that. Find the area under the curve, written as yucky business. Just a second. Which, by the way, this is also another way, which this this is normally what you're gonna see, and normally what you have to be able to evaluate, was what's the interval from -3 to 3 for this function? Find the area under the curve. That's what we generally do. But I'm showing you this in case that one multiple choice question that's worth 2 points scaled up, so actually 4 on the AP exam, 4 points out of 108. Yeah.
So the 1/dx just represents like.
Oh,
one step
sorry,
change.
sorry. It's not 1/dx, it's dx. Whatever dx was, and in this context of this question, the dx was a 1.
Because that's the step each rectangle takes.
And
Yeah, so, okay, let me show you actual business. So there are some on Delta Math, and I have some of them snapshotted here for us to look at. And all that, like, don't write this down, but this is how calculus was kind of created, was we're gonna have these partitions. So those are the slices that we did our trapezoids or our rectangles. And we have any arbitrary x sub 1 to x sub 2. And we're gonna find the integral, so the area under the curve, with height times width. And we're gonna make that partition width really, really, really skinny small, and we're gonna add all the tiny little slices of area. That's what this stuff is saying. Okay. So here's the kind of practice on Delta Math. They're like, okay, here's this function. We're just gonna call it f of x. And we have 25 slices. So how many areas are we calculating? 25. So this index goes from 1 to 25 rectangles, right? And they want to use RAM to find the stuff from 0 to 2. What's the dx going to be in this case?
Um,
So from 0 to 2, so this distance cut into 25 little slices, okay? So it's not over dx, it is the dx.
Yeah.
Okay. And here's the tricky thing. How do we, as a single thing, I want this to move with the index. I want the height here first, then here, then here, then here. How do I write a something? F of,
N times 2/25? Or, yeah.
okay, where does it start?
0.
So just for myself, from the starting point, the first step, at 1, it said RAM, so I needed to take this step first. So I'm going to add that one step to it. So 2n over 25, let's see. Oh, sorry, K. They used K. And Delta Math and AP will yell at us if we use the wrong letter. I didn't even look. So, meh? First time I saw these on the exam, like, I don't ever teach this. First time I saw it on the exam, I'm like, what are they talking about? What are they doing? Okay, so I don't know how to make this bigger so you guys can see. 20 subintervals. We're integrating from 2 to 7. Nope. What would you fill in? Okay, so it's still RAM. So it's instead of 0 plus. Daniel says it's 2 plus. How many slices did we say? 20? So what's the dx gonna be? 20 divided, or 5 units cut into 20 slices, so 1/4. Okay? And how do I get these guys?
Times 3 plus 1/4 n.
Okay,
K.
f of the x value where it started plus the step. And if it was LRAM, I don't want to change a whole lot. Did I do that? Does that give it LRAM? I went from 0 to 19, still 20 little slices, but I'm saying find the height here. Does that work? Computer science-y?
Could you do it with MRAM, or do you do it only a thing for MRAM?
MRAM would just be 2 plus instead of 1/4, that you go to the
Wouldn't it be
2
just-
point, 2 plus an eighth plus k over 4.
You just change the starting value.
Correct.
Okay.
So, there. So this is, I'm not going to test you on this. I might give you a few delta maths related to this as the AP exam gets closer, so that you'd be like, all right, when we talked about it for that 3 minutes in class, made a little bit of sense. I'm not gonna test you on it, but I'll give you another, delta mathy thing so you can fight with it as the exam gets closer in case they put it on there. And there's different styles which we'll deal with. Okay. Back to our regular stuff. Today's supposed to be definite integrals. And an exit card. Hopefully you all saw the email about that. Friday.
And you said 11 10.
Right, so I'm setting an alarm to make sure that I shut up in time. So this thing says every continuous function you can integrate. So, do. Doesn't have to be differentiable, but if you can draw it without picking your finger up, you can find the area under there. And here's potentially irritating news. Even if it's discontinuous, we might still be able to integrate. We can't integrate over all discontinuities, but we can over some.
So just hold the discontinuities? Or what?
Hold that thought. Not infinite, but jumps we can do as well. So if it's continuous, we can integrate it. There are some that we can never find analytically, like we can't do it with a process of like undoing power rule or something. You need to just use geometry, which is why I had the geometry warm up a couple days ago. Some of you allergic to geometry, it's not bad. It's not. Okay. All this is trying to say, hey, partitions, blah, blah, blah. Where calculus kind of evolved from, they went from, let's find the areas of all these rectangles of width and height and find an infinite number of those rectangles. Supposedly the sigma stretched out and became this symbol, that's like a tall stretched out S, I don't know. And whatever, this is what we're mostly dealing with. Okay? And I don't know that you need to know the names of things. If you were looking at grading rubrics, because, you know, it's fun to do that, they do not usually take off if you do not have this variable on there. Small exception is if there's multiple variables and you needed to pick the right one.
What is that?
It's the width, right? We're finding areas of rectangles, it's the width. And poor thing, they're calling it a dummy. Gosh. But it's just to say your width and your height. But grading rubrics, they often say, did you get the integrand right? Did you get the limits of integration right? So you're not going to be asked to know the vocabulary of it, just there it is. It's called a dummy variable because the answer does not depend on the variable chosen. Not exactly true. When you get to multivariable calculus, if you integrate with respect to x versus y versus z, there's differences. Okay. All right. I don't care. Don't know why they say non-negative. Okay, if these are actual areas, like space that I had to paint, this is 5 square feet, this is 8 square feet. If I actually integrated from A to B, what would that be? -3. Because that area is below the x-axis, it's negative. So I don't like, because they change their mind later, they're like, oh, we can generalize this. This means I went 5 feet forward, 8 feet backwards, I ended up 3 feet behind my starting line. That's what integration is, it's area under the curve, and if it's below the x-axis, it's negative. Okay. There's a problem though. Sometimes they ask you to integrate backwards. Okay, okay. This is your stock price and woohoo, my stock price went up. If you went back in time, is your stock price still going up? No, right? Like, so if you went back to, I don't know, January versus now, like, oh, January to now, my stock price is up here. And then there was, wait, oh, that dip. If you went back to January, your value was much less. So we will get to fanciness with that soon, but same thing. Area above is positive, area below is negative. Okay. This first one, even in June, when you are done school, you will not know how to integrate this other than with geometry. So how do we do it with geometry?
Carefully.
Okay. Valid advice.
Split it into, let's say, 4 separate rectangles.
Well, what does the graph look like?
Questions?
I can find the answer to this exactly. What does it look like?
Semicircle.
Semicircle. How do you know that?
It's a square under a square.
Squared under the square root. Well, it's different if it's x squared minus 4. But if I do a little squishing the stuff around, okay, I agree. Now I recognize it. It's a semicircle centered at the origin with a radius of 2. Gee, we did this problem a couple days ago. What's the area? 2 pi, thank you. first period fell right into the trap, because 2 days ago when I did it, I was like, the thing you guys are gonna get wrong is you're gonna do everything, but you're gonna forget to cut it in half. You didn't. They said it was 4 pi. Their caffeine hadn't quite worked yet. But this one, still, like, the end of class, in June, you're not gonna be able to integrate this any other way. You've gotta see it as the semicircle that it is. This one, graph it and find the area. Yes. Yeah. Remember, expires soonish. And Constantine would love to do it on the board.
I would.
He would. He would just thoroughly enjoy that.
So I have to do it?
Yeah, sure. Why not? You know, live a little
Alright.
in front of your 8 colleagues. 12. 12.
So it's from -2 to 2.
Mm-hmm.
So it looks something like this.
So, y-intercept of +1, x-intercept of -1.
So now like that.
Super close. The area is
Negative
+1/2, but it's below the x-axis, so it's negative
So just B9.
8/2, so it's 4.
Yeah.
Okay. So here's to show you with area, you could do this any number of ways. He found the area of this triangle and the area of that triangle, subtract the little one from the big one, and had it, which this looks just like the one I drew first period, which, not hating, but drawn to scale. It was a little clearer that the triangle below and the triangle above canceled each other out. So maybe just don't even calculate that. And some students found the area of the trapezoid as a single calculation. I don't care. To me, they're the same thing, and they take about the same amount of time. So it's whatever you're more comfortable with. Good? Ish? Preguntas? Okay. That one is super fast. And it's discontinuous.
This is 0.
It says it's at 0. What's it look like?
I feel like I've just seen this problem before.
What's it look like? So,
Yeah, it's just like 1.
first period, some people did that, some people did this, well, with this being straight. And then some people did the right thing. A rectangle above, a rectangle below, same size rectangles.
Isn't there also, no, it's, never mind.
So this is a discontinuity. I can't integrate at 0. I can't plug in at 0, but I was able to find the area anyway. Is this function even, odd, or something else?
Odd.
Odd. It spins around the origin. What's another odd function?
X cubed.
Trig function? So here's a thing. There's a reason we ask you to have some understanding of even and odd. If I ask you to integrate an odd function symmetrically over the origin, what's that gonna be? The bubble up and the bubble down, so it's gonna be 0. You don't even have to think about it, be like, yo, 0. From negative 21 to positive 21, 0. And how do you, A to negative A? 0. You can be all like smart. We're not doing that. We're not doing that either. Okay, so like to get you started on the exit card is on Delta Math. You can use the whiteboards as like scrap paper, and you can use the calculator that's inside Delta Math itself.